This is section 2.5 in our second review unit. We're going to focus on translating written expressions. So our essential question for this lesson is, how do you translate written statements into algebraic expressions or equations? And this is one of the most difficult things in math sometimes, because this is the idea of taking what's in the word problem, translating it into the mathematical statement so that you can solve the problem. Okay. So we've talked about this before. There's 4 operations in mathematical expressions or equations, and those are add, subtract, multiply, or divide, right? And so these are the 4 main operations that we're going to be dealing with. Of course, sometimes there's exponents, sometimes there's parentheses and other things we have to worry about. But these are the 4 main things that we're interested in identifying in a written expression. So there's many ways that we use words to indicate each one of these things. And part of that's good because we've got lots of choices, but part of that can be kind of frustrating because there's so many different ways to represent each one of these operations. So I'm going to go through a few of the most common words that mean each one of these operations, and then we'll practice using those in some sentences. Okay, so if we look at addition up here, so we have addition, right, up here. Some of the most common words that mean addition, and this is certainly not an entire list, but some of the most common ones, and we'll add to this as we go. So maybe leave some space underneath your list so we can add some words as we find them in different problems. But of course there's add, there's plus, the word sum means add, more than. So if I have more than you, you might add to your amount to figure out what my amount is, something like that. And then of course we have increased by. If you look at subtraction, obviously we have subtract, we have minus, we have the word difference, means subtract, so the difference of 2 numbers. This one, let's put a little star by this one because this one is particularly tricky, less than. This one's tricky because sometimes we know that less than means an inequality, but sometimes less than is going to mean subtraction. So we have to use the context of the problem to figure out which one of these it's going to be. And then we have decreased by. All right, let's look at multiplication and division. To multiply, obviously, we have multiply. We have times. Those are 2 of the obvious ones. Of course, product means multiply the product of 2 numbers. And let's put a little star by of. Of almost always means multiply in a written statement. And it's one of those words to watch out for. And then we also have increased by a factor of. If you see that word factor, that's going to indicate multiplication. Twice means multiply by 2. Double means multiply by 2 as well, so we'll watch out for those. And of course triple means multiply by 3. Now let's look at division. Of course we have divide. Then we have the word quotient. So the quotient of 2 numbers is telling us to divide those 2 numbers. If we are decreasing by a factor, that's going to tell us to divide as well. And we have to be careful of this one because sometimes you could represent this as multiplication, sometimes you could represent it as division because those 2 operations are related, right? If I want half of something, of course I'm going to divide by 2. If I want a third of something, of course we'll divide by 3. Now like I said, these lists are not the entire list. We can certainly add to these lists as we go along. So leave some space in your notes so we can keep adding words that indicate each of these operations. Okay? Alright, so let's do a few examples. If I want to write the difference between 5 and a number, look back on your list, remember that difference means subtract, right? And we want to go in the order that we see. So we have 5 and a number. And notice I'm underlining the important words here. I don't know what that number is, so I can use x to represent that number, or any other variable. So since I'm looking for the difference between 5 and a number, the 5 comes first, and then we'll subtract x. If I have 7 minus a number, all right, we're going to do the same thing this time, but this time maybe I'll use n for my number. That's a really common one to do too. So 7 minus n. All right, in my next example, this one's really tricky. We have 4 less than a number. Now in this case, I know that this is talking about subtraction, not the inequality. If it were the inequality, I'd be looking for is less than. And that's not what we have here. So I know it means subtract. But this time, let's use x for our number again. It's actually going to be x minus 4. Let me try to write that down again here. X minus 4. So how come it's x minus 4 and not 4 minus x? Well, think about it. If I want 4 less than a number, that's like saying 4 fewer. That means I have to take away 4. Oh, look, here's 2 more things we could add to our list under subtraction. Fewer and take away. So I have to take away 4, so my expression will be x minus 4. That's going to give me 4 less than the original number that I started out with, which was x. Then if we have a number, let's use n this time, decreased by, that's on my subtraction list again, 9, and it's going to go exactly in this order. So I'm going to take away 9 from my unknown number. So n minus 9. Perfect. All right, let's do a few more examples. You can notice that every single one of these examples had subtraction in it, right? All right, so what about this one? The product of 9 and a number. So underline our important words. We see product. That tells me to multiply. And we're going to multiply 9 and a number. So if we use that as x, we could write 9 times x. But really, in algebra, we're just going to write 9x because that means multiply. All right, here's another one. 1/4 of a number. Remember how I said of almost always means multiply? Well, let's look at that as multiply here. We have 1/4 of a number, so 1/4 times x. So we could write that as 1/4 x. We could also write that as x divided by 4. Now we have the quotient of a number in 6. So again, quotient meant divide. So we're going to divide n by 6. So I can write it that way, n divided by 6. Or more frequently, the way that we'll want to write that expression would be n over 6. We're going to write it as a fraction because, believe it or not, it's actually easier to deal with this statement than it is this statement in algebra. So we'll write that as n over 6. If we say a number increased by 7, we're not increasing by a factor of 7, we're just increasing by 7. So that means addition. So this time we'll have x plus 7. Perfect. All right. Now, all of the previous examples we've looked at have been just expressions, right? We're just writing a mathematical statement with no equal sign or inequality sign. Just add, subtract, multiply, divide, just variables and constants. So how does this change when we're working with equations and inequalities? Well, when we're writing an equation, I want you to look for the word is, or of course, is equal to. That word is a huge indicator that what we're going to be writing is an equation. If you're lucky, it'll say is equal to, because that's a huge indicator that we use the word equals. But usually, we're just going to see the word is. When we're writing an inequality, now we're going to look for the words is less than. Not just less than, but is less than. Or maybe is less than or equal to. Is greater than, or maybe is greater than or equal to. Okay? So get those down in your notes and then we'll do some examples of this. The sum of a number and 12 is 6. So we've got quite a bit to underline here. We have sum, that tells me add. A number, I don't know what that is. Well, actually I do know what that is. It tells me that the number is x. So I'm going to add x, and I'm going to add that to 12, and then it tells me is 6. So is 6 tells me it equals 6. So this expression, or this equation, actually will be x plus 12 equals 6. So we found the sum of a number and 12 equals 6. So that's my equation. Let's do the next one. The quotient of 15 and a number x is less than 3. So quotient tells me to divide. 15 and a number x tells me what I'm dividing. And then is less than. That tells me this is going to be an inequality. So the quotient of 15 and a number means we're going to divide 15 by my number x, and that division is going to be less than the number 3. So 15 divided by x is less than 3. Or if you wanted to, you could write it like this, but again, this inequality is going to be much easier for us to work with in algebra. Okay, next one. The product of 5 and a number is 25. Product, we know that means multiply. 5, and it tells me that my number is x, and then is 25. So is means equals, so we're going to have the product of 5 and a number. So 5 times x, we write as 5x, is 25 equals 25. Awesome. One more. The difference between 13 and a number is 7. Difference tells us to subtract. Between 13 and a number, it doesn't tell me what my number is, so let's use a different number this time. Let's use a. And then is 7. Again, that is right there tells me equals. So the difference between 13 and a number would be 13 minus 7. Oh, excuse me. 13 minus my number, which we don't know, we call it a, is 7. So 13 minus a equals 7. Perfect. Okay, so go back and look at all those different examples. Make sure you include some questions about what represents each one of the operations, what words represent each of the operations, how you can tell the difference between when something is an expression, an equation, or an inequality by looking at the words that are used in the statement. Get your 3 to 4 sentence summary, get your questions done, and that's it.